150 years ago, a single climate event killed more people than both world wars combined. Between 1876 and 1878, a super El Niño triggered simultaneous droughts across 3 continents, sparking famines that wiped out somewhere between 30 and 60 million people, roughly 3% of the entire population of Earth at the time. Climate scientist Deepti Singh at Columbia University, who has spent years reconstructing exactly what happened during those years, has described it plainly as arguably the worst environmental disaster to ever befall humanity, a disaster no single climate event before or since has come close to matching. And right now, in 2026, forecasters are watching a super El Niño build in the Pacific that has already been placed on a trajectory to exceed the strength of every El Niño ever recorded in the modern instrumental era, including the 1877 to 1878 event that produced this staggering historical death toll. To understand why an ocean temperature anomaly thousands of miles from any farmland could kill tens of millions of people, you have to understand what actually happened during those catastrophic years. Normally, trade winds blow steadily from east to west across the tropical Pacific, pushing warm surface water toward Asia and Australia, while allowing cold, nutrient-rich water to rise up along the coast of South America. When an El Niño develops, those trade winds weaken or reverse, and the warm water that would normally sit in the western Pacific drifts eastward instead, fundamentally reshaping rainfall and temperature patterns across the entire planet. The 1877 to 1878 event did not happen in isolation. It coincided with a record-strong Indian Ocean dipole and unusually warm Atlantic sea surface temperatures, an alignment of multiple major ocean systems, all pushing in the same direction simultaneously. Researchers studying the period describe what followed as not a regional disaster, but a synchronized global catastrophe. Monsoons vanished over India, rivers ran dry across China, the Brazilian sertão turned to dust, and African harvests withered at the same time across 3 separate continents. If you're finding this as significant as I did digging into it, do me a favor and hit that like button. It genuinely helps this channel grow. India bore the heaviest single toll from what became known as the Great Famine of 1876 to 1878, with estimated deaths in the country, ranging from 5.6 million up to nearly 10 million people, depending on which historical demographic estimate researchers use. The famine began after an intense drought caused crop failure across the Deccan Plateau. But what made the disaster so severe was not solely the failure of the monsoon rains. India still produced enough food to avoid catastrophic famine that year, but colonial policy under British rule ensured devastation regardless. Grain exports to England continued and even swelled to record levels. Throughout the crisis, with the viceroy at the time overseeing the export of 6.4 million hundredweight of wheat, even as millions of Indians starved. Relief camps that were established paid famine workers a daily wage of just 450 grams of grain. Plus, a single Anna, for a full day of hard labor performed without shade or rest. Florence Nightingale, upon learning the scale of what was unfolding, wrote in 1877 that the more one heard about the famine, the more one felt it represented a hideous record of human suffering the world had never before witnessed. China suffered similarly catastrophic losses during the same period, with the drought contributing to one of the deadliest famines in that country's long history, killing millions of people across several northern provinces through the combined pressures of crop failure, food shortages, and the diseases that inevitably followed mass starvation and displacement. Brazil's northeastern region, known as the Sertão, endured what became known as the Grande Seca, a great drought that devastated the region's agricultural economy and displaced enormous portions of its population. Drought conditions extended even further than these headline disasters, with tree ring records showing dry conditions reaching into Egypt, Morocco, Australia, and even portions of southwestern and eastern North America during the same multi-year window. Tree ring-based drought reconstructions used by researchers to study the period suggest that Asia's drought during these years was the worst recorded in at least 800 years, an almost incomprehensible scale of climatic disruption driven fundamentally by ocean temperature. Anomalies that most people at the time had no framework whatsoever to understand or connect to their suffering. If this kind of historical and climate science content is something you want more of, make sure you subscribe, because there is a lot more of this coming. The scientific reconstruction of exactly why this El Niño produced such an extraordinarily severe and long-lasting global drought, rather than the more typical regional disruptions El Niño events usually cause, comes from detailed research published in the Journal of Climate by Singh and her colleagues. Their analysis found that the extreme severity, duration, and geographic extent of the 1876 to 1878 drought was associated with an unusual and rare combination of preceding conditions: unusually cool tropical Pacific temperatures, persisting from 1870 through 1876 that set the stage for what followed. Then the record-breaking El Niño itself, peaking in 1877 and 1878, occurring alongside a record strong Indian Ocean dipole in 1877, and record warm North Atlantic Ocean conditions in 1878. It was this specific combination of multiple major ocean systems, all reaching extreme states within the same narrow window, that researchers believe explains why the resulting drought proved so much more severe and so much longer lasting than a typical strong El Niño event, which usually produces significant but geographically limited and shorter duration impacts. That precise combination of factors is exactly what makes the current developing 2026 to 2027 El Niño event a subject of such serious scientific attention. As of mid-August 2026, NOAA's Climate Prediction Center has placed a 69% probability on this event, exceeding the strength of every previous El Niño on record dating back to 1950. With a 90% probability, it ranks among the strongest ever observed in the modern instrumental era. Sea surface temperatures in the key equatorial Pacific monitoring region have already reached 2 degrees Celsius above average, the threshold that formally classifies an event as a super or very strong El Niño. Compounding the concern further, a positive Indian Ocean dipole is developing concurrently alongside this Pacific warming, the exact same combination of simultaneous ocean anomalies that researchers identify as the critical amplifying factor behind the catastrophic severity of the 1877 to 1878 disaster. The World Meteorological Organization has already explicitly flagged this specific combination of a strengthening super El Niño and a positive Indian Ocean dipole as capable of amplifying regional climate impacts, including drought, flooding, and wildfire risk, well beyond what either system would produce operating on its own. The obvious and unavoidable question this historical parallel raises is whether the world could actually face a repeat of a disaster on the scale of the Great Famine. Researchers studying this question are consistent in offering a measured, carefully qualified answer rather than either dismissing the risk or predicting an inevitable catastrophe. Modern meteorology, global food trade networks, and agricultural monitoring systems substantially reduce the immediate likelihood of a famine reaching the scale of the 1876 to 1878 catastrophe, primarily because today's world has forecasting capabilities that simply did not exist a century and a half ago, along with international food distribution networks capable of moving surplus grain to drought-stricken regions far more efficiently than 19th century colonial infrastructure ever could. Vimal Mishra of the Indian Institute of Technology, Gandhinagar, reflecting on what the historical Great Famine teaches modern climate planners, told reporters that studying the event gives researchers a clearer idea of how to be better prepared, framing the 1876 to 1878 catastrophe as essentially a demonstration of the absolute worst case scenario that this kind of extreme compound climate anomaly is physically capable of producing. That reassurance, however, comes with a genuinely serious caveat that climate researchers are careful not to gloss over. Climate change can amplify extreme weather events, and vulnerable regions around the world remain at real risk if governance, systems, food storage infrastructure, and social safety nets fail to function adequately during a severe multi-year drought event, regardless of how much better modern forecasting and food distribution technology has become compared to the 19th century. The 1876 to 1878 catastrophe was not purely a product of extreme natural climate variability operating in isolation. It was, as extensively documented by historians studying the period, a product of both rare and extreme oceanic conditions combined directly with human vulnerability, specifically colonial economic policies that prioritized grain exports over feeding starving local populations. That historical lesson about the compounding role of human systems and governance failures during a climate crisis remains directly relevant today, since a severe multi-year drought striking multiple major agricultural regions simultaneously would still place extraordinary strain on global food markets, potentially triggering export restrictions, panic buying, and price spikes capable of pushing food access out of reach. For vulnerable populations, even in a world with vastly superior forecasting and logistics compared to 1877, the current 2026 Super El Niño is already producing measurable global impacts well before reaching its projected peak intensity later this year. Analysis of global temperature records shows the first half of 2026 ranked as the third warmest half year on record across every major data set, trailing only 2024 and 2025, both of which occurred during the peak and tail end of the previous major warm cycle. Climate researchers project that 2027, as this El Niño's full effects continue propagating through the global climate system, could reach approximately 1.7 degrees Celsius above pre-industrial levels, comfortably setting a new record for the warmest year in the entire instrumental temperature record. This pattern reflects what climatologists' individual El Niño event functions as a step upward, riding on top of the steadily rising baseline created by long-term human-caused greenhouse gas warming, meaning each successive major El Niño tends to set new global temperature and climate impact benchmarks that exceed the ones set by the previous major event, not simply because any individual El Niño is unusually powerful on its own, but because the underlying baseline it is building on top of keeps climbing higher with each passing decade. For the agricultural regions across South and East Asia, East Africa, and South America that suffered the most catastrophic losses during the 1876 to 1878 event, the developing pattern in 2026 carries genuine relevance for planning and preparedness. Early signals from the current El Niño combined with the developing positive Indian Ocean dipole have already produced measurable rainfall. Anomalies across exactly the regions historically most vulnerable to this specific compound climate pattern, with Indonesia and Australia already experiencing elevated fire risk and suppressed rainfall, while parts of East Africa and the Arabian Peninsula have seen enhanced rainfall anomalies tracking the Western Indian Ocean warming. Whether these early signals ultimately develop into anything approaching the severity of the historical Great Famine remains genuinely uncertain and will depend heavily on factors extending well beyond the ocean temperature data alone, including how effectively national governments, international aid organizations, and global food distribution systems respond as the peak of this record-strength El Niño event approaches over the coming months. There is also a lesser-known chapter of the 1876 to 1878 disaster years that adds an additional, often overlooked dimension to the historical record: the extraordinarily violent tropical cyclone activity that struck the Bay of Bengal during the same broader climate-disrupted period. In late October of 1876, just as the drought conditions driving the Great Famine were beginning to take hold across the Indian subcontinent, a supercyclonic storm now known as the Great Bakargunge Cyclone struck the Bakargunga district of British-controlled Bengal with sustained winds reaching 220 kilometers per hour. The storm killed an estimated 100,000 people, ranking it among the deadliest tropical cyclones ever recorded anywhere on Earth, striking a population that was simultaneously beginning to face the earliest stages of the drought and famine conditions that would go on to claim millions more lives over the following 2 years. While researchers have not definitively established a direct causal mechanism linking this specific cyclone to the developing El Niño pattern the way they have for the drought impacts, the timing illustrates just how much simultaneous climate stress this region absorbed during those catastrophic years, compound disasters arriving in overlapping waves rather than as isolated sequential events. That historical detail matters for understanding the full scope of what an extreme compound climate anomaly is capable of producing when it strikes vulnerable populations without adequate warning systems or emergency infrastructure in place. Modern meteorology has closed much of that warning gap, and organizations tracking the current 2026 Super El Niño are issuing detailed advisories months in advance of anticipated regional impacts, giving governments and aid organizations a genuine head start that 19th century populations never had access to. Whether that head start translates into meaningfully reduced human suffering compared to the historical benchmark depends less on the raw meteorological science, which has improved dramatically since 1877, and more on how effectively the warnings scientists are already issuing get translated into concrete preparation, resource stockpiling, and coordinated international response across the specific regions. The data suggests are most likely to bear the heaviest burden as this record-strength El Niño event continues building toward its projected peak.